This lecture is on coordination chemistry, specifically on isomers. Isomers have the same molecular mass and molecular formula, and if so, then the follow-up question is, does the pair of molecules have the same spatial arrangement in respect to all chemical bonds per substance? If yes, the relationship are stereoisomers. If no, the relationship are structure isomers. For structure isomers, there is a follow-up question. Do all of the same ligands bind to the metal ion? If yes, they are linkage isomers. If no, they are coordination isomers. Linkage isomers are species where the ligand has more than one donor atom to bind to the metal ion. Examples include SCN- and NCS-, NO2- and ONO-. To the right are a pair of linkage isomers whose formula is CO NH3 5 NO2 2+, where the difference is the donor atom connected to the metal ion center. The left structure has the nitrogen atom in NO2- ligand bind to the cobalt metal ion, and that is the nitro isomers. The right structure has the oxygen atom in NO2- ligand bind to the cobalt metal ion, and that is the nitrito isomer. Coordination isomers are isomers that involve an exchange from either the cationic or anionic part of the complex. An example of the cationic exchange are FeH2O6, COCN6, and COH2O6, FeCN6. An example of the anionic exchange are AuH2O4, ClCnBr, and AuH2O4, BrCnCl. For stereoisomers, the follow-up question is, are the pair of molecules non-superimposable images? If yes, they are optical isomers. If no, they are geometrical isomers. We will look at some possible geometrical isomers. Planar isomers that have geometrical isomerism are ones with a molecular form of Ma2B2. The left set of structures are cis isomers because identical atoms are on the same side of the plane, whether on top, on the bottom, left side, or right side. Trans isomer, shown on the right, has like atoms across one another. An example is PTNH32Cl2. The left structure is the cis isomer, and the right structure is the trans isomer. Octahedral isomers that exhibit its geometrical isomerism are ones with one of three molecular formulas. One is Ma4B2. The cis isomer has the B ligands both on the same side of one of the trigonoplanar structures. The trans isomer has the B ligands on opposite ends of the two respective trigonoplanar structures. An example of this isomer is CONH34Cl2+. 2. Ma3B3. The facial isomer has three identical ligands and the center atom on one face of the octahedron, and the meridian isomer has the three ligands coordinated in the plane, which includes a metal atom. An An example of this isomer is CrNH33Cl3. Three, Ma2B2C2. This form has 5 total isomers. One isomer is all cis, one isomer is all trans, and 3 isomers is a mixture of cis and trans isomers in respect to the ligand. An example illustrating these 5 different isomers is CuH2O2, CO2, Cl2. Optical isomers are enantiomers or mirror images that cannot be superimposed on each other. The figure to the right illustrates how one can view an optically active hand on the left and a coordinated complex of COEN3, 3+. Here we have a pair of stereoisomers, cis COEN2Cl2 plus and trans COEN2Cl2 plus. Only the cis isomer is optically active because the structures are not superimposable. Here is a review exercise for you to work on. Do any of the following stable octahedral complexes have geometric isomers? If so, draw them. A. CONH35Cl plus. B. CONH34H2O2 plus. For the remaining part of this lecture are solutions to review exercises or problems. Please view only after completing these exercises.